Integration sequence Alpha 7 is green. All systems report nominal. The vehicle is ready for transfer.
Once the engines are integrated, this core stage will deliver the thrust needed for deep space travel.
Welcome to the cutting edge of space exploration. I'm Dr. Sarah Mitchell, Chief Propulsion Engineer, and I've dedicated 15 years to building the rockets.
Cultures. Building a rocket requires materials that can withstand 3,000 degrees Celsius combustion, pressures exceeding 3,000 psi.
Architectures. Rocket structures demand the ultimate strength-to-weight ratio. Aluminum lithium alloys save hundreds of kilograms while withstanding long.
Carbon composites revolutionize rocket design, enabling larger tanks, lighter structures, higher performance.
This massive autoclave cures the carbon fiber nose cone under intense temperature and pressure. The result structure is
Rocket engines operate under unimaginable conditions, pumping cryogenic propellants at thousands of gallons per second.
combustion chamber fabrication. Copper alloy inner liner with integral cooling channels. Channels machined to route cryogenic fuel. Propellant tanks are the rocket's largest components, storing hundreds of tons of cryogenic liquids and it is
Pressure stabilization complete. All systems nominal.
Validation confirmed. We are good for flight certification.
Turbopumps are among humanity's most extreme rotating machinery, generating pressures equivalent to ocean depth.
Sequence initiated, confirming full range of motion on the x-axis.
Thrust vectoring stable. All parameters green.
These engines produce thrust equivalent to 40 jumbo jets, yet must operate reliably for
First stage assembly is performed vertically, the position it will launch. Propellant tanks, engine section, avionics.
First stage assembly is performed vertically, the position it will launch. Propellant tanks, engine section. Torque on bolt 7 is complete.
Reading green on the tablet. Sequence verified.
Avionics integrated and secured. Check.
Pressure holding steady at 2,500 psi.
Check.
Recalls. The engine section must withstand and distribute thrust from multiple engines, forces exceeding 2 million pounds. The engine section must withstand and distribute thrust from multiple engines, forces exceeding 2 million pounds.
Lower the cluster to final position. Confirm structural integrity.
Roger that, engineer. Securing the main bolts now. Torque is steady.
Flight computers guide the rocket from liftoff to orbit insertion crits, processing sensor data thousands of times.
Flight computers guide the rocket from liftoff to orbit insertion, processing sensor data thousands of times per second.
Sensor array 4B is fully integrated and showing green.
Confirmed. Telemetry looks nominal from here.
Confirming all accelerometers are in the green. Propellant level sensor L3 reading is stable.
FTS installation complete. All parameters are nominal.
Confirmed, we are green across the board.
FTS connection secure. Verified against schematic.
Range safety confirms installation complete.
Modern reusable rockets incorporate landing systems, grid fins for atmospheric steering, landing legs for
Modern reusable rockets incorporate landing systems, grid fins for atmospheric steering, landing legs for touchdown.
First stage complete, the site. On 150 feet of precision engineering containing 9 rocket engines. First stage complete, 150 feet of precision engineering containing 9 rocket engines. Propellant for 3 minutes.
Dimensional checks confirm alignment within tolerance.
Initiating solar array deployment.
The caliper reading is 45.2 millimeters.
That aligns perfectly with the specification sheet.
We can proceed to the vibration sequence.
Upper stages operate in vacuum where atmospheric pressure and drag don't exist. Engines optimized for vacuum with expansion nozzles over 10.
Upper stages operate in vacuum where atmospheric pressure and drag don't exist. Engines optimized for vacuum with expansion nozzles over 10.
Run the diagnostic sweep on the integrated harnesses.
Telemetry is green across the board.
Good install.
Engine putter. Stage separation occurs at 60 kilometers altitude while traveling 6,000 kilometers per hour. Explosive bolts release.
Stage separation occurs at 60 kilometers altitude while traveling 6,000 kilometers an hour. Explosive bolts release.
Bolt is seated. Go ahead and apply torque.
Applying torque now.
3 clicks.
Verified.
Payload fairings protect satellites during launch, withstanding aerodynamic forces and heat, then splitting apart in space.
Payload adapters are custom for each mission.
providing structural attachment, electrical connections, and clean separation.
Alignment looks good. Pin 5 is seated.
Confirmed. Proceed to secure.
Applying torque. Sequence initiated.
Fairing encapsulation is the payload's last view of Earth before space. Protected inside, satellite will travel through.
Completion verification. Upper stack ready. Integration approaching.
Final integration connects all stages. First stage booster, upper stage, and payload section.
Systems testing validates all components work together, coordinating engine gimbal, propellant valves responding to
Static fire testing validates propulsion system, engines fired at full thrust while rocket held to test stand. Verifying
All parameters are perfect.
Confirmed. We are green for flight.
Final verification is exhaustive. Every system tested, every reconnection verified, every document reviewed.
All systems are reporting green. Manager, we are ready.
Safety confirms all certifications are met.
Very well. We are go for launch site. Proceed. We've built and tested the rocket. Every system verified, every component certified. Now it's time.
Transport to launch pad is carefully choreographed, rocket moving horizontally at walking speed. Support.
Launch pad provides everything rocket needs until launch. Propellant loading, electrical power, environmental control.
Ground power synchronized. Umbilicals reporting full telemetry. We are go for internal power.
Propellant loading occurs hours before launch. Ultra-cold liquids filling tanks while continuously venting to maintain temperature.
We're approaching full tank on the LH2.
Copy that. Pressure holding steady.
Full propellant load. Rocket now filled with exuberant energy. Continuous
range safety. Verify tracking systems.
Tracking locked. Flight path clear.
Destruct system armed status.
Armed and ready, Chief. Go for launch.
The wind shear is acceptable, but the anvil cloud development and lightning risk near the pad violate criteria. We are currently no-go.
T-minus 10 minutes and counting. Launch sequence initiated. The terminal count has begun.
Launch control monitors thousands of parameters, propellant levels, engine status, weather, range safety.
T-minus 1 minute and counting. The flight computer has control. Engines are chilled. The vehicle is ready for flight.
3, 2, 1.
Ascent is safe and revealed. First stage burns for 3 minutes, accelerating to 6,000 kilometers an hour, then
Ascent is 8 minutes of precision then. First stage burns for 3 minutes, accelerating to 6,000 kilometers per hour, then separate. Upper stage provides final velocity increment, burning until precise orbital parameters achieved. Then coast phased positioning payload for deployment.
Mecho complete, trajectory stable.
Copy that. Houston confirms orbital insertion.
Mission Control coordinates launch operations, dozens of specialists monitoring systems, tracking trajectory, ensuring mission success.
We have orbital insertion!
Congratulations, everyone. We did
it! Well done.
Rocket manufacturing evolves continuously. 3D printed engines, automated assembly, AI quality.
This is the dawn of a new era. Fully reusable systems are unlocking the solar system.
From reusable systems to methane propellants producible on Mars, we are pioneering sustainable spaceflight for long-term exploration.
From the moon to Mars and beyond, we are becoming the architects of our destiny among the stars.
What an extraordinary journey from factory floor to orbital flight. Every rocket represents this.
I'm honored to work at the frontier of human achievement, building machines that defy gravity, enabling science.
The next generation of rockets will take us farther, the moon, Mars, and beyond.